Bob and Fred start from the same point and walk in opposite directions. Bob walks 2 miles per hour faster than Fred. After 3 hours, they are 30 miles apart. How fast did each walk? Okay, I drew a dot on the board. This is where Bob and Fred are going to start. And Bob is going to go in that direction. And Fred is going to go in this direction. And after 3 hours, they are 30 miles apart. Now, does this look similar to the other problem? Well, it is. In the other problem, they started at opposite ends and they worked toward each other. And in this problem, they're starting at the same spot and they're walking in opposite directions. And we gave you that as one of the clues that it was going to be D1 plus D2 equals D total. We don't know how far Bob is going to walk and we don't know how far Fred is going to walk, but we know that together they're going to walk 30 miles. So that is going to be the D total. So here are our slots again, and they look exactly the same, except instead of J1 and J2, we have Bob and Fred. Bob is going to be the first walker. Fred is going to be the second walker. And let's start filling in some of these slots. It said that Bob was walking at the same speed as Fred, only 2 miles an hour faster. So why don't we take Fred's speed, which is R2, and add 2 to that. And that's what that means. Whenever you see that somebody is walking 2 miles an hour faster or 10 miles an hour faster, whatever that is, you put the other person's speed, which is R2, plus 2. And now let's come down to Fred. We're going to put R2 for Fred. Remember, if Bob is R2, Fred is going to be R2. Now, it's not going to be the same R2, but there's going to be a relationship there to where we get rid of one of the variables. We've gotten rid of one of the variables now. Now, let's look at the distance. We know that 30 is the total distance, so we're going to put 30 minus D2 there. And make sure that it's always minus D2 or minus D1, it doesn't matter which one you do, but make sure that it's minus variable. That is, the distance that they give you is going to be positive, and what you're subtracting is the variable. Don't do D2 minus 30, or you're going to be really messed up. Anyways, we're going to do 30 minus D2. For D2, we're going to put D2. And did they give us time? Yeah, they did. They gave us a time of 3 hours. So let's just put that down for both of them. And now we have enough information to build our first formula. D1 equals R1 times T1. You already know that. D1 is 30 minus D2. And that's going to equal R2 plus 2 times 3. Now, since we're multiplying 3 times R1, that is R2 plus 2, let's put that in parentheses. So there you go. There's our first formula for our first object in motion. And D1, and those are the values we put in for D1. Go back to the grid and look at that. Equals R1, and those are the values we put in for R1, times T1. And that's the value that we put in for T1. Okay, that's complete. Let's build a formula for the second body in motion. As you can see, it's going to be pretty simple. D2 equals R2 times 3. Yeah, just like that, except that we like the coefficient in front of the variable, so let's change that. Yeah, D2 equals 3 times R2. And that is the only variable, if you look around here, that's the only variable where there's an equal sign after it. That is, we know what D2 equals. D2 equals 3R2. And we have a D2 up here, So let's insert the value of 3R2 here, and let's get rid of this. So there we go, we've substituted that in. And remember, there was a negative sign there before, so we're going to just let that negative sign stay there. And you can see that we've eliminated all the variables again, started off with 7 variables, and we've got it down to 1 variable. Now, let's pull this out of the parentheses. And there are no like terms, so let's bring the negative 3R2 over here. Bring all that down. Let's move the units over. Bring all that down. Divide both sides by 6, which isolates R2. And 24 divided by 6 is 4. So we know the rate of Fred. Let's see how fast Bob was walking. Let's go back to the grid. Put that 4 in for Fred. Bob is Fred plus 2. That would be 6. And that's your answer. Bob is walking at 6 miles per hour. And Fred is walking at 4 miles per hour. Make sure you put that miles per hour in there, or mph, something like that. And let's fill in the rest of the grid. For Fred, 3 times 4, R2 times T2, that would be 3 times 4 is 12. For Bob, R1 times T1, 3 times 6 is 18. And so that's the distance he covered. And 18 and 12 is 30, which is the distance they were supposed to walk together. And so all of that pans out. All of that looks good. I know that isn't the question, but it's a good way to check your work. And it's a simple way to check your work. I mean, we just did a lot of work, and checking it is real simple at this point. Now let's do another problem. 2 campers left their campsite by canoe and paddled downstream at an average speed of 12 miles per hour. They turned around and paddled back upstream at an average rate of 4 miles per hour. The total trip took 1 hour. After how much time did the campers turn around downstream? Now, if you look at that word total, that should be a tip-off, because that is going to be the total time. Now, that's very common for total time problems, is somebody went here and then they went back. Somebody hiked up a mountain and then they ran back down. And they were gone for 14 hours, or in this case, they were gone for 1 hour. So is the time you are given the total time? If it is, T1 plus T2 equals T total. Subtract T1 from both sides, just like we did for distance. And we're going to end up with T2 equals T total minus T1. And of course, you can end up with T1 equals T total minus T2. It doesn't matter which way you do it. Just make sure that the total is positive and the T1 or the T2 is subtracted. So here's our grid again, and as you can see, it's exactly the same except on the side. For the first object in motion, I've written down, and for the second object in motion, I've written up. Okay, they don't give us the distance, so you have to ask yourself, what is the relationship of D1 to D2? Is it D1 equals D2? Well, yeah, they're starting at a campsite. They're going downstream a certain distance. And at a certain point, they decide to turn around and go back upstream, back to the same campsite. So both distances are going to be the same. So D1 equals D2. And for both of our slots there, you can put D1 or you can put D2. It doesn't matter. Let's just put D1. And they gave us the speeds. R1 equals 12 and R2 equals 4. And that kind of makes sense. Going downstream, you're going to go a lot faster than when you paddle back upstream. And for T2, we're going to say 1, that is 1 hour minus T1. And for T1, we're just going to put T1. So for our first formula, I think you can see that's going to be D1 equals 12 times T1. There you go, that's pretty simple. And our second formula is going to be D1 equals 4 times parentheses 1 minus T1. Do you see that? Look in the grid. Remember, it's going to be D2 equals R2 times T2. D2 equals D1. That's the value we put in. R2 is going to equal 4. And T2 is going to equal 1 minus T1. So that's the formula for our second body in motion. And why don't we bring that out of parentheses, 4 times 1 minus T1. So we have a simple formula for D1 here. We have a simple formula for D1 here. So we can substitute this into this, or we can substitute this into this. And since this is a little bit simpler, why don't we substitute the 12T1 into the second formula? Now you can do it either way, it doesn't matter, but that looks the simplest to me. There we go, and again we're down to one variable. Let's bring that 4T1 over to the left-hand side of the equation. Bring all that down. Divide both sides by 16, which isolates our T1. And that's our answer, except that it needs to be reduced to 1/4, and since we're talking about time, it's 1/4 of an hour. We're going to leave it as 1/4 of an hour. We're not going to say 15 minutes because as we start substituting it back in, we're going to have to start converting minutes to hours, and you don't want to do that. But let's go back to the grid. T1 equals 1/4 of an hour. T2 equals 1 minus 1/4, which would be 3/4 of an hour. And let's see what the question was. After how much time did the campers turn around downstream? In other words, how long were they going downstream? And the answer is 1/4 of an hour. It didn't ask how long they were going upstream. It didn't ask how long they were gone total. They told us how long they were gone total. They were gone for an hour. So that makes sense. Downstream, 1/4 of an hour. Upstream, 3/4 of an hour. Together, that's 1 hour. 12 times T1, 1/4, equals 3 miles. R2, 4, times T2, 3/4. 4 times 3/4 equals 3 miles. And we know that D1 equals D2, so they're both supposed to be 3 miles, and they are. We have filled in all of our slots and it all makes sense, and that is the correct answer, 1/4 of a mile. So like we discussed previously, that was 2 trips disguised as 1 trip. And another thing that they did is they put 2 people in there as if they're making 2 separate trips. And you'll see that every once in a while, that Betty and Bobby are walking down the street and they're doing the same thing. Okay, just because there's 2 people, that can still be one body in motion. And that's what happens here. And that makes sense if you think about it. In a canoe, how many people paddle in a canoe? Usually 2. I mean, you can have more than that, but you usually have at least 2 people paddling in a canoe. If you don't, it's a kayak, isn't it? I don't know. But anyways, let's do our next problem.